Genique? Our next question is, find the charge needed within a unit sphere centered at the origin for producing a potential V is equals to minus 6 r power 5 divided by epsilon naught for r less than 1 is. So previously we have solved a problem based on the potential function. Okay, by using the potential function we have found what we have found? The electric field intensity. But here what we have to find? We have to find the charge. We have to find the charge. Previously we find what? Electric field intensity. Here we have to find the charge needed to produce the electric field. The charge needed within a unit sphere centered at the origin for producing a potential of this one. Okay. So how can we find this? So how can we find the charge? So is there any relations we are having? So if you know we know the voltage. Only we know the voltage. So is there any relation between the voltage and the charge? Okay, is there any relation between the voltage and the charge? And there is a relation between the voltage and the charge. Okay, so how we have to use this relation now? So if you observe this, see, here one relation is given. So due to the point charge, there is a relation 1 divided by 4 pi epsilon r cube is there. Sorry. So this is what? The voltage. The voltage is equals to due to the point charge. Due to the point charge is equals to q divided by 4 pi epsilon r. So this is what? Due to the point charge. But here there is no point charge. It is not a point charge. It is a spherical surface is given. So that's why we cannot use this kind of relation here. So is there any other relation? So we search for it. Okay. So come to the next topic. Suppose, observe this. Find the charge needed within a unit sphere centered at the origin for producing a potential. V is equals to minus 6 r power 5 divided by epsilon naught. So if you take any potential, see, if you take any sphere, it is producing a potential. On the surface as V is equals to minus 6 r power 5 divided by epsilon naught. That means it represents what? It is an equipotential surface. So while we are talking about the equipotential surface, it is now we commonly go for conductor. Equipotential surface means it may be a conductor surfaces or something else. Okay, suppose wherever you find equipotential surface, so suppose if you want to find the voltage function, we should go for the Poissons and Laplace inequations. So what is the Poissons and Laplace inequations? So find the Poissons and Laplace inequations. What is the Poissons and Laplace equations? We know what is that Poisson's equation? Del square V is equals to minus rho V by epsilon. Understand? Suppose if you take any charge free region, this is called as what? It is a Poisson's equation. Okay, I am not deriving it now. Okay, it's a very simple by using del dot D equals to rho V. Okay, it is the charge density. So if you take any charge free regions, what happens? If you take any charge free region, the rho v will be 0. There is no charge. So that's why del square v is equals to 0. This is called as what? A Laplacian equation. Laplace equation. It is a Laplacian equation. Okay. So these are the two equations are there to find what? See, if you use this, observe this. If you use this equation, can we find the charge? No, because observe this. Only del square v is there. It is equals to 0. There is no charge term here. But if you observe this, del square v is equals to rho v by epsilon. Charge density is there. If the charge density is there, you can find the charge because the sphere is given. Understand? So if you find the charge density, it is simple to use. It is very simple to use what? This one. Find the charge. Okay. Now come to the equation. So what is del square v? This question, what has given? V is given. The v is given in what? It is given in spherical coordinates. It is given in spherical coordinates. Right or not? It is given in spherical coordinates. V is equals to minus 6 r power 5 divided by epsilon naught. Okay, r. Because it is given also sphere, we have to know that it is given in the spherical coordinates. So what is del square v? Del square v is equals to, how can we find the del square v in the spherical coordinates? Is there any relation? To find del square v, there is one shortcut here, 1 divided by h1, h2, h3, okay, dou by dou u of h2, h3 divided by h1, dou v by dou u, okay, plus dou by dou v of, dou v means what? The v which is present in the tabular form, okay. So dou v by dou v of h1, h3 divided by h2, it is dou v by, this is v, it is this scalar, it is what is v I am writing here, this is this v, okay, this is dou v divided by dou v, I am writing small and big, okay, plus dou by dou w of h1, h2 divided by h3, dou v divided by dou w, and they are very helpful everywhere. So that's why I am specifically stressing on these kind of problems. Okay. Suppose, so this is given. So now what is del square v? Del square, find del square v. Del square v is equals to, del square v is equals to what? Minus, 1 divided by h1, h2, h3, spherical coordinates, r square sin theta divided by dou by dou r of h2, h3. h2, h3 is what? r sin theta, r square sin theta divided by h1 is 1, dou by dou r of dou v by dou u, dou v by dou r of what? What is v? V is this function, okay. So minus 6 r power 5 divided by epsilon naught. So this is, so is there, what about other terms? Other terms will be 0 because observe this, it is the function only in r with respect to theta and with respect to phi. This function, the partial derivative of that function will become 0. So if you observe this, it is r square sin theta is there. Here r square sin theta is there. You cannot what? You cannot make it cancel because you can make it cancel only the sin theta. that you cannot cancel r square sin theta entire. Okay, r square will be kept only because this r square is in the derivative term. So this will be equals to 1 divided by r square. What about this? What about this? This is r square. Okay, this is r square. So dou by dou r of r square into what is this one? Dou by dou r. First of all, find this. So this will be equals to minus 30 r power 4 divided by epsilon naught. So this will be 1 divided by r square dou by dou r. This one is what? R power 6. So you can directly write here minus 30 divided by epsilon naught. Minus 30 divided by epsilon naught. This is r power 6. R power 6 means, if you one more time, if you differentiate this will be into 6. This will be into 6. So 6 into, already I have taken, this is 1 by r square is also there. Right, 1 by r square. So this will be 6 r power 5. So if you observe this, how much it will be? It will be minus, it is 180 r cube divided by epsilon naught. Understand? But observe this, we got the del square v. But if you use the Poisson's equation, what is del square v? Del square v is equals to minus rho v by epsilon naught. Or epsilon naught. If there is epsilon, see, it is for epsilon. I am assuming this is a free space. Here you can also write, because that is given epsilon naught, you can also write epsilon naught unless he mentioned the epsilon r value. Okay, by assuming epsilon r is 1. So this is equivalent to what? This is equivalent to this one, right? So you can cancel this one and this one. So from this, what can I write? So from this, rho v is equals to 180 r cube. This is the volume charge. I hope you got it. Okay. So now this is del square v. So from this, what we have to find? The rho v is obtained. What is rho v? 180 r cube. So 180 r cube. So from this, how can we find the charge? The charge is equals to what we have to find? Find the charge needed. The charge needed within the sphere to produce that field. But from this, charge density is there. It is rho v dv. Rho v dv means what? It is a volume integral, right? So dv is nothing but what? It is triple integral. Triple integral of rho v dv. Rho v dv is nothing but what? In spherical coordinates. Here also the spherical coordinates. In the spherical coordinates, h1, h2, h3, du, dv, dw. So r square sin theta dr d theta d phi. Okay. So where r is equals to from 0 to 1, because it is given. It is less than or equals to 1. So what is theta? Theta is equals to 0 to pi. Here phi is equals to 0 to 2 pi. So the limits are very important. So that's why in the coordinate systems, I told you the ranges of the each and every parameter. So if you simplify this, what I will get? So it is what? Integral of, it is rho v. Rho v is nothing but, I am writing triple integral. This is 180, rho v is 180 r cube into r square, r power 5, sin theta dr d theta d phi. So if you simplify this, you will get 180 r power 6 divided by 6 from 0 to 1, and sin theta, it is minus cos theta, it is what? 0 pi. And if I integrate with sin theta d theta, you are getting this. If I integrate only with pi, here you will get only pi only, d pi only pi only, this will be 2 pi. Understand? Minus is there, this will be what? It is 30. If you write this, it will be 30 into 1. 1 into cos pi, minus 1, it is 2 into 2 pi. So finally what you are getting? It will be 120 pi coulombs. So this is the final answer. Okay. So in this way we have to proceed. Okay. I hope you understand. Welcome to Genique. So observe this next question. The question is, the electric field strength at a distance point P due to a point charge plus Q located at the origin is 100 microvolts per meter. If the point charge is now closed by a perfectly conducting metal sheet sphere whose center is at the origin, then the electric field strength at the point P outside the sphere becomes, these are the options: 0, 100 microvolts per meter, minus 100 microvolts per meter, D, 50 microvolts per meter. So understand the question, what he has asked. See, there is a point charge is located, there is a point charge located at the origin. Okay, the point charge is located at the origin. This is plus Q is located at the origin. Now the electric field strength at a distance point P due to the point charge is what? 100 microvolts per meter. So due to this, here let us suppose at point P, okay, at point P, the electric field intensity is 100 microvolts per meter. It is the given data. Now what happened? Now if the point charge is now closed by a perfectly conducting metal sheet sphere whose center is at the origin, then the electric field strength at the point P outside the sphere becomes, okay. So now this is closed by a metal sheet, okay. Now this point charge is now closed by the metal sheet. Which kind of metal sheet it is? Which kind of metal sheet is it is? It is a perfectly conducting metal sheet. It is important. It is a perfectly conducting metal sheet. Okay. So this is the question. Now before this, without this sphere, it is producing, this is the electric field. Now this sphere is encircled by one sphere. Now the charge is closed by the conducting sphere. This is what? It is a conducting sphere. So you should know one thing. Already we have seen this kind of problem. If there is a conducting sphere, so due to this entire result, we have to, due to this entire arrangement, we have to find the electric field. Already before this, without this sphere, we got electric field intensity, this one. Now if it is closed by the sphere, then what would be the electric field intensity? We have to find. See, it is a conducting sphere. So because it is a conducting sphere, what happens? The charge in this entire sphere will be, what happens? It goes to the, what happens? It goes to the, this one. This entire charge will goes to here. Understand? So on the surface, the entire charge will be onto the surface. Okay. So if there is any charge, this entire charge will go to the surface. Understand? Now you have to know one thing. So there is a point charge here. There is a point charge here. Okay. But this point charge is, what happens? The point charge, because of this point charge, we know this, and on this surface there will be what? The charge particles will be presenting. They will be rotating, there will be conducting. So because of this positive charge, what happens here? Because of this positive charge, the charges will be, the negative charges on this surface will be attracted into the sphere, but it will not come here. But all the charged particles will present at the surface, negative charges. These all are negative charges. These are all minus, not dots. Okay. The negative charges will come and reaches the inner surface of the sphere. Because of this positive charge, it will attract the negative charges on the sphere. What happens? Now the metal becomes, the outside surface of the metal becomes what? Then the outside surface of the metal becomes the positive charge. Here it will become the positive charge. Now you have to identify how much amount of negative charge will be induced in the inner surface of the sphere. You have to, it is a fundamental question. How much amount of the negative charge will be induced into the attracted into the surface of the inner surface of the sphere? It is equivalent to the charge placed at the origin. So what is the amount of the positive charge? See, observe this. What is the amount of the positive charge? The positive amount of the positive charge is plus q. So if it is plus q, the equivalent amount of the negative charge will be attracted to the inner surface of the sphere. So if it is attracted, the negative charge is attracted inner surface, then what happens? Only the positive charge will be present on the outer surface of the sphere. Okay. So like this, what happens? So now application of Gauss law. Come to the, what we have to find? We have to find the electric field intensity at a point P outside this. Okay. So to find the electric field intensity, what happens? We will use the Gauss law. Okay. From Gauss law, what happens? So to find the electric field intensity, if I apply the Gauss law, you have to consider one surface. Which surface? A Gaussian surface has to be imagined outside the sphere and where the P is located. Okay. So we have to assume this Gaussian sphere. Now what happens? What happens? So what happens now? So here, what is the total net flux leaving? The total net flux leaving is equal to the charge enclosed in this volume. Okay. What is the total charge enclosed in this volume? This is plus q. What about this? It will be minus q, because the negative charge equal to the charge inside this, at this place. So it will only attract this amount of negative charge only. So all these negative charges equal to the plus q. But what about the outer sphere? The outer sphere is positively charged. How much? The outer sphere will be positively charged of how much? It is plus q. That is the thing. Understand? Or otherwise, what happens? What is the entire charge? The entire charge is plus q. So plus q. So due to this, what happens? Or otherwise, what happens? Here, this will be, or these two are also will get cancelled, or this one also will get cancelled. You can cancel anything. You can cancel the charges, this charge and this charge, because these two are equal. Or you can also cancel this charge, this positive charge and negative charge, and they will cancel. The resultant charge is 0. Okay. What I am trying to say that is, the net charge on the sphere for a conducting sphere will be 0. The net charge accumulated on the conducting sphere will be 0. See, observe this. So this is the thing. So what is that net charge? It is plus q. So plus q, if there is a sphere, so there is no effect here. See, so due to this entire charged sphere, what is the sphere is? The sphere is now charged plus q. Okay. So now what will be the electric field? The electric field will be same, because what is the total charge? The total charge is q on this. So you have to take the electric field intensity from the center to the point only. Okay. So that's why what happens? So because of this cancellation, you will get the same effect, because the total flux leaving this entire surface is equal to the same, only it is equal to plus q. Okay. Or otherwise, you can also say, because of this is a conducting halo sphere, so without assuming this plus q, plus and negative minus, so what happens? This is a conducting sphere, this will go to the surface. This will go to the surface. What happens? If it goes to the surface, so what will be the total charge? The plus q only, any of the ways. Okay. So now what will be so while we are calculating the electric field, you have to take the distance from the center. Even though the charge is placed on the sphere, you have to take the distance from the center of the sphere only. So that's why you will get the same amount of the electric field intensity. So this is the concept. Understand? So now it is just like when the positive and negative charges are cancelled, what happens? Only this plus q will be there. So due to this resultant only plus q only, we are getting this one. The answer will be the same. Understand? So like this, the questions will be asked.